if you go back to concrete design, if you go back to steel design for beam, your beam in a regular position that we have x-axis, y-axis, x-axis, y-axis. Your applied load is a vertical load, which means in y direction will cause moment about x. For concrete, your load is in a vertical direction, in the same direction of y. Your applied moment, which is called phi mn, will be about x-axis. But right now, your applied load not in x direction or in y direction. So I will do some change or some component. For w, in y direction will be w cosine theta, in x direction will be w sine theta. So we have two components. One component in y direction and another component in x direction. Component in y direction equal your dead load plus your live load after multiplied by your factor 1.2, 1.6 cosine your angle. If you would like to get the x direction component, your dead load plus live load time sine your angle. So we have two cases or two components, one in a y direction and the other one in x direction. Any question so far? Any question so far? Do you agree with me? The issue is why we have this issue right now. For two reasons. The first one, your dead load and live load, no way, must be vertical. Your cross section must be inclined a little bit with angle theta. Why? Because this beam or this purlin supported by something called main system, and your main system looks like this with inclined roof. So we have a vertical load. I have no option. It must be vertical. I have inclined member. I have no option. Supported with inclined roof. So we have angle in between. So we have two components, one in y and one in x. It's very easy. Once you get your dead load plus live load, factor dead load plus factor live load, cosine your angle, you can get the y component. Sine your angle, you can get your x component. Any question so far?
What is a sag rod?
What?
What is the sag rod?
Okay, this is second step. Okay, the second one. If you watch your cross section, most of the time, your cross section has very strong direction and another weak direction. Most of the time, your cross section has the strongest direction about x-axis. So mx or your design moment about x will be large, very strong. Your cross section very strong about this direction. But about y, weak. I will not say very weak. No, weak. Not large or not strong enough like x direction. So we suggest, maybe it's okay or not, it's up to you. We suggest in this direction we can add something called sag rod or rod to connect between purlins at midspan in this direction. If you are talking about moment about x-axis, the total length of your purlin is working. If you are talking about moment, about y-axis, which is weak, no. Your beam becomes simple beam between this main system and this rod. Or simply supported between this rod and this main system. So I decrease the length of your Berlin, which is working about y-axis. This part needs more. Okay. Let's see. What is that? Column. Steel column. Here is your y-axis, here is your x-axis. If you have concentrated load here, and this load will make buckling, what do you think? This column will buckle about x-axis or about y-axis?
Y-axis.
Yes. Y most of the time is the weakest direction. So if you have concentrated load here, I am worrying your column will buckle something like this. Not something like this. Do you agree? Okay. So I have issue with this direction. Okay. At this location, I will add here beam. And this beam will be continue on the other side, like this. So your beam make confinement for your column at this location. So if your column would like to buckle in the same direction, will buckle like this. Do you agree? So I made my column stronger by reducing the free length. I will not do beam on this direction. Why? Because I don't need. Your column is very strong about this direction. So the total length of your column, it's okay. But your column is very weak another or about the other direction. So I would like to make it stronger. It's okay. I will not leave your column with the total length to buckle like this. No. I will make support at mid-span or mid-height to make your buckling something like this. You got it? The same reason. Your Berlin for the total length is strong if you are talking about x-axis. But your Berlin for the total length about y, it's not strong enough. So I added something in between Berlins at mid-span to make support. So your beam in y direction will be from this point to this point on. But your beam around x-axis from this point to this point. So if you are talking about M ultimate x, we are talking about the total span of your Berlin from this point to this point. Remember, this support is your main system. This support is your main system. And the S is the distance between main system and the main system. So I can get my MX. But if you are talking about MY, No, here is your main system, that's fine. Here is your main system, that's fine. In between, we have rod, which called sag rod. This one. So your beam will be from this point to this point, which is S divided 2. So your moment will be W L square over 8. Your L is S divided 2. One more thing. If you are looking for moment about X, your load in Y direction, WY component. If you are looking for moment about Y, your load in X direction. Moment about X, your force and your distance, one of them must be in Y and the other one in Z. So if your load in Y direction, your moment will be X. If your load in X direction, your moment will be My. Anyway, so your component in Y direction will make Mx. Your component in X direction will make My. Your distance for Mx is the total distance of your Berlin. Your distance for My is half distance because this direction is weak. So we made our Berlin stronger by reducing your distance to 2 bars. Any questions so far? It's complicated a little bit, I know, but if you follow the steps, it's okay. One more time. If we go back, start with your dead load, on weight, covering, then go ahead and calculate your live load, that's fine. We neglect wind load. Then your load, your vertical load, will have 2 components. One in Y direction, equal to this equation, and another one in X direction, equal to this equation. Your moment about X-axis, ultimate moment about X-axis equal this component, W L square divide 8. Your L for moment about X, the total length of your Berlin from main system to main system, which is called S. If you are talking about My, your moment about Y will use this component and have distance between main system because you added sag rod. Once you get your Mx and My, we are done. According to AISC, this interaction equation must be valid. M ultimate X that you calculated before divided by phi MNX, which called design bending moment about X, equal plus M ultimate Y that calculated before divided by 0.5 phi MNY, which is your design bending moment about Y. This one plus this one must be smaller than or equal 1. This term and this term was calculated before. That's right. M ultimate X and M ultimate Y. The denominators, this term equal phi F yield Z X. This term equal phi F yield Z Y. This number divides this number plus this number divides this number. Don't forget 0.5. All of them must be smaller than or equal 1. So the best scenario, assume cross section, do your calculation, apply your interaction equation, must be valid smaller than or equal 1. If this value is greater than 1, your cross section unsafe. You need to increase it. If this value far away from 1, like 0.3, that means your cross section is more safe. So the best scenario, this term or this side something around 0.9 to 0.95. That means you selected the best cross section for Berlin. The commonly used cross section for Berlin channel, something like this. And you have a table called Design of Berlin for all dimension and all cross section for channel. Any question? Let's do an example.
So we have to find for the channel, the C channel, we have to find that, use that table.
Yes, 4 channels. We have roof system consists of truss of the type shown in the figure below, spaced 15 feet apart. So this information is important. Your S equal 15 feet. Distance between main system, 15 feet. So this truss is repeated at equal distance equal 15. Purlins are to be placed at the joints and at the midpoint of each top chord member. We have sag rods will be located at the center of each purlin. Anyway, so we have purlin here, 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 for any reason, sometimes, but we don't recommend this. To add purlin at mid distance of your member. We don't recommend it, but for this example, that's fine. The total dead load, including an estimated purlin weight, is 21 pound per square feet. And your life load is given 21 pound per square feet. So if you would like to get your W dead load, remember, in the given example, your value 21, which is dead load, including the on weight of your purlin. So your W dead load will be 21 times what?